Hello everyone. All right, this lesson ties together the relationships between elasticity and total revenue. We call it the total revenue test. So the first question would be, well, how is it that total revenue and elasticity are related? This is the way you can figure that. Remember first that elasticity is defined to be the ratio between the percentage change in sales, that's upstairs here, and the percentage change in price. So for example, if you cut your prices 10% and you discovered that your sales jumped up, say 50%, that'd be 50 over 10, you get an elasticity value of 5, and we would call that elastic. Similarly, if you cut your prices 10% and your sales only went up, say 2%, that would give you a ratio of 2 over 10, or 0.2, and we call that inelastic. So first, remember this relationship between sales and price and how it is used to define elasticity. Then second, remember what total revenue is. Total revenue is P times Q. So can you see that when you cut the price, this is going to have a tendency to drive total revenue down, but at the same time, when you cut the price, sales will go up. That will tend to drive total revenue up. So it is the interplay of these two things, P and Q, in total revenue that's related to elasticity. So finally, remember that a demand curve, of course, it's obvious, slopes down to the right. So when the price goes down, quantity demanded goes up. So the only reason this bullet point is here is just to stress to you that these two things are working opposite of each other in their impact on total revenue. All right, here we go. So if you move along a demand curve, one variable is increasing total revenue while the other one is decreasing it. So here's the total revenue test by its formula. So again, here's the formula. Total revenue equals P times Q. If you raise price, then obviously quantity will go down. And it really depends on which one of these is the biggest that impacts whether total revenue is going to rise or fall. This is obviously driving total revenue up, and this is driving it down. And it's the interplay of those two forces that affect total revenue and, of course, affect elasticity. So this is only here to show you the other way. If you lowered the price and sales would go up. Same idea. So here is the total revenue test in words. If, when prices go down and total revenue goes up, then it must have been that you're in the elastic part of the demand curve. That would happen because price goes down and sales went up so much that it drove total revenue up. It would have been elastic. Similarly, if prices went down and total revenue goes down, it must be inelastic. So in this case, when the price went down, sales went up, but not enough to offset this, so we would call that inelastic. And finally, the third one is just, my old professor called it the knife edge case. It's the one that's neither elastic or inelastic. So if when price goes down and total revenue turned out to stay the same, they're perfectly balanced, it wouldn't be elastic or inelastic. We would call it unitary elastic. So these are the rules, the total revenue test and its 3 rules. Now you might find in a book somewhere another 3 rules, but basically it's just these 3 going the other way. So instead of price going down, there are rules for when it goes up, and here they are. So when price goes up and total revenue goes down, then it must have been elastic. When price goes up and total revenue goes up, had to be inelastic. And then the knife edge case, when price goes up and total revenue stays the same, must have been unitary elastic. Now, I know what you're thinking. You're thinking, God, that's 6 rules. How am I going to remember all that? It's impossible to remember. Well, I agree. It's not a good idea to memorize those rules. It's too hard to remember all of them, and at least it is for me, and it's too easy to get them backwards. So I don't, I got a PhD in economics. I don't have those rules memorized. I basically just figure them out every time I need to use them. In my opinion, it's much easier to memorize the graph that relates the elasticities to total revenue, and I want to show that to you. I find it much, much easier than trying to remember those 3 or 6 rules. So here we are graphically. So just start with a demand curve. All of you, I hope, already very familiar with this. Here's our demand curve. Here's the corresponding marginal revenue curve that goes with that demand curve. Remember, it shares this point in common with the demand curve, and it falls at twice the rate. So just making up a number here, if this number right here were 100, marginal revenue is falling at twice the rate, so this number would be 50. Okay, so now down here, let's put total revenue. Remember now, total revenue is price times quantity. So over here at this extreme point, we got a big number for quantity, but we got a 0 number for price. So 0 times that big number, say 100, 0 times 100 would be 0. So total revenue is 0 here. And similarly, total revenue is 0 over here for kind of the opposite reason. We got a big number for price, but we got a 0 number for quantity demanded. So that big number times 0 is again 0. So total revenue starts at 0, it rises up, it's maximized dead square in the middle, then it begins to fall, and again it's 0 over here. For any straight line demand curve, this is what total revenue looks like. So I put this little dotted line in here to relate these 3 things: the top of the total revenue curve and where marginal revenue is 0, and this point right here, which is dead square in the middle of the demand curve. So the top of the demand curve is elastic, and I'll show you from the rule how that is. And the bottom of the demand curve, the bottom half of the demand curve, is inelastic. That will always be true for any linear demand curve, no matter if its slope is steep or flat, but as long as it's a straight line demand curve, the top half is elastic and the bottom half is inelastic. So you can see it here. When total revenue is rising, it's elastic, and when total revenue is falling, it's inelastic. So I set up a slide to show you one example. So here we go. Let's pick a price kind of high up here in the elastic part. So here's price P1. Here's the quantity demanded that goes with that high price. And here's the total revenue that goes with that price P1. Now let's let the price fall, say to P2. So sales go up, right, from here to here, sales go up. And notice what happened to total revenue. Total revenue went up. We dropped our price and total revenue went up. So that's elastic. We're in the elastic part. Now, let's try again. Down on the low side of the demand curve, say price P3. So here's some price. Here's the quantity demanded that goes with price P3. And here's total revenue that goes with price P3. Now let's let the price fall to P4. Here's the quantity demanded that goes with P4. And here's the total revenue that goes with P4. Notice that when we went from P3 to P4, total revenue fell. So we're in the inelastic part. In my opinion, this is the best way to remember the relationship between total revenue and elasticity. To remember this graph. It's much easier, I think, to remember this graph than it is to remember all those rules. Now, as you look at this graph for the first time, maybe, you might think, it doesn't look too easy. But really, there's only 3 things here. There is a demand curve. There is its corresponding marginal revenue curve, which you need to know anyway, and its corresponding total revenue curve, and they're all related. This is elastic, total revenue is rising. This is inelastic, total revenue is falling. When marginal revenue is positive, which would be up here, you're in the elastic part, and over here, when marginal revenue is negative, you'd be in the inelastic part. Okay, that's it. I hope you found that simple. And now the next lesson will be on multivariable demand curves. And I'll do some of that in PowerPoint, but really we probably need to do it in Excel. Okay, I hope you found that helpful. Goodbye.